Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the August 2016 Geometry Common Core New York Regents exam. Alright, let's take a look at question number 16. It says, what are the coordinates of the center and the length of the radius of the circle represented by the equation x squared plus y squared minus 4x plus 8y plus 11 equals 0? Alright, so let's go over the center radius form of a circle real quick. Okay, so recall, if you have the center radius form of a circle, which is given by x minus h squared plus y minus k squared equals r squared, the center is given by the opposite of the number next to the x would be the x coordinate h, and the opposite of the number next to the y will be the y coordinate of the center, and then your radius is going to be the square root of the number to the right of the equal sign, r. Okay, so what we have is the general form. We have the general form x squared plus y squared minus 4x plus 8y plus 11 equals 0. So we have the general form. What we're supposed to do first is to convert this into the center radius form. Okay? If we place it in the center radius form, then it's easy to determine what the center and the radius are. So let's go ahead and do the conversion. So first things first, we're going to organize our x's and y's next to each other. So we have x squared minus 4x plus y squared plus 8y. Now 11 doesn't belong to the x's or the y's, so what we'll do is we'll move it to the other side of the equation, and then we have it equal to negative 11. Now what did we just create? We have created two incomplete squares. So what do you think we're going to do next? We're going to proceed to complete the squares with the x's and the y's. Now to help us keep them separate visually, let's go ahead and place a partition down the center. So we're going to have x squared minus 4x plus a certain term that makes the x component of the left side of the equation a perfect square trinomial. Okay, and then for the y area, y squared plus 8y, we're going to add another number that will make this a perfect square trinomial. Alright, in order to make our equation the same, to preserve equality, whatever we added to the left side of the equation, we have to add exactly the same thing to the right side. Okay, so we're going to add the number that makes the x's a perfect square trinomial, and add another number that makes the y's a perfect square trinomial. So what are these numbers that we're talking about here? To complete the square, you simply add b over 2 square. That's how you complete the square. Okay, so let's deal with the x's first. So for the x, the b for the x is negative 4. How is that so? Imagine this is written in standard form. A is a coefficient of x squared, which is 1. B is a coefficient of x, which is negative 4. So what are we going to do with this value of b? Well, we are going to follow the formula written up here. We're going to divide it by 2 and square it so we can know what makes the x side of our partition a perfect square trinomial. So divided by 2, you get negative 2. And you square that. Negative 2 squared is 4. Okay, so we're going to add 4 here. And then we also add 4 to the other side of the equation to preserve equality. Now how do we complete the square in the y side of our partition? Same procedure. b for the y is 8. We're going to divide that by 2, which is 4, and square it. Okay, 4 squared is 16. So we're going to add 16 here and add 16 here. Now let's go ahead and factor out our perfect square trinomials. Since they're perfect square trinomials, there's a shortcut that we can use to factor them. Just root the first and the last term in the x side of the partition and drop down the middle sign. So that yields x minus 2 quantity square, okay, plus, because we have a plus right here. Same thing with the y's. Root the first and the last term in the y side of the partition. So that yields the square root of y squares y. And do not forget to bring down the middle sign. So we have y plus 4 quantity square equals, here we have 11 plus 20, negative 11 plus 20, which is positive 9. So what have we accomplished thus far? We now have the center radius form of the equation of a circle. Okay? The nice thing about this, as indicated earlier, is that we can easily determine what the center and the radius are. So let's go ahead and rewrite the formula down here, and then we can extract h and k. Okay, so the formula is, let's see, x minus h squared plus y minus k squared equals r squared. Okay, so we can easily see what the center is. Center, which is hk, is given by, you take the opposite of negative 2, which is positive 2, and the opposite of positive 4, which is negative 4. There goes your center. And your radius, we know that r squared, you got to be careful here, r squared is equal to 9. So if r squared is equal to 9, what is r? You take the square root of both sides. R is simply 3. Okay? So center 2, negative 4, radius of 3. Our answer is option number 1. Alright, let's take a look at question number 17. It reads, the density of the American white oak tree is 752 kilograms per cubic meter. If the trunk of an American white oak tree has a circumference of 4.5 meters and the height of the trunk is 8 meters, what is the approximate number of kilograms of the trunk? Okay, so reminder, connection between mass, density, and volume. You need to remember this formula in order to solve this problem. Okay, so the mass, in this case we're going to be looking for the mass of a piece of trunk of the oak tree. Mass is density multiplied by volume. Okay, alright, so the density is already provided for us here. The density is 752 kilograms per cubic meter. The mass is what we're looking for. Okay? We need to find the volume. Since we have just one equation, we can only have one unknown. Now, what are we looking for the volume of? If you think about the geometric shape that closely resembles a trunk, we're looking at a cylinder, okay? A circular prism. So let's say we have the trunk looking something like this, okay? So we want to find out what the volume is. So you can go to your reference sheet, or you might already know what your formula for volume is. Volume is equal to the area of the base, pi r square, multiplied by the perpendicular height. Okay? So what dimensions do we have for the trunk? We know that the circumference is 4.5 and the height h is 8. In order to find the volume of this trunk, we need the radius and the height. Okay, so the height is 8, which is good. Now, what on earth is the radius? We do not know. We have a clue that can help us find the radius, okay? So, that clue that helps us find the radius is the circumference. The circumference is 4.5. Now, what is this formula for the circumference of a circle? Circumference of a circle in terms of the diameter is just pi times the diameter, okay? And we know d is the diameter is twice the radius. Okay, so c is equal to pi d, or c is equal to 2 pi r. We're going to be looking for r so that we can determine what the volume is. Okay, alright, so what is the circumference? The circumference is 4.5. 4.5 equals 2 pi times the radius. Okay, so how do we proceed? We want to figure out what the radius is, right? So to get r isolated, we're going to proceed to divide both sides of the equation by 2 pi. Okay? Divide by 2 pi. Now we can find out what the radius of that piece of the log of wood is. So the r is going to be 4.5 over 2 pi. So let's put that right here. 4.5 over 2 pi. Now we are in a position to find the volume. Okay, if we know what the volume is, we'll plug it in here, and then we can find what the density of the trunk is. Okay, so now let's go ahead and find the volume. Let me partition my workspace here. So it's like we have 3 problems in one. First of all, you have to find the radius, and then use the radius to find the volume, and then use the volume and the density to find the mass. So for the volume calculation, we're going to use the volume formula we stated earlier. V is equal to pi r square h. So the volume here will be pi times the radius square. R square is 4.5 divided by 2 pi square times the height, which is 8. So we'll plug that into the calculator. So we're going to have, let's see, pi times 4.5 divided by 2 pi. Let's make sure we enter this properly. So 2 pi, we have 2 terms in the denominator, so we group it like that. 2 pi, close that, raise it to the second power, and multiply by 8. We get 12.89155. So the volume is 12.89155. Now we are ready to compute the value of the mass. Okay, so we're going to take this value and plug it right here. So our volume is 12.89155. Let's go ahead and find out what the mass is. So the mass is equal to, let's write down the formula again, density times volume. Density is 752. Volume is 12.89155. We'll find the product using our calculator again. So we already had the previous result there, so we can just simply multiply it by 752. When you press multiply, it automatically copies the previous answer as your first entry, and then the operation, and then it allows you to enter the next values. So I already entered it. 752 is the value of the density. Okay, when you multiply it, you have 9,694.46. 9694.4, not 46.45. The problem wants us to round it to the nearest whole number, so we're just going to round it to the ones place. So if we approximate it to the nearest kilogram, is going to be 9,694 kilogram. Answer to number 17 is option number 2. Let's take a look at question number 18. It reads, point P is on a directed line segment from point X, -6, -2, to point Y, 6, 7, and divides the segment in the ratio 1 to 5. Question, what are the coordinates of point P? Okay, so we're going to get started by taking a look at the formula for a segment divided in a particular ratio. All right, so let's write down the formula first, and then we'll apply it to this particular scenario. Formula is as follows. If, let's say, point P, x sub P sub y sub P, let's say that's the coordinate, divides a line segment from A. Let's say the first point A is x1, y1. A line segment from A, x1, y1 to point B, coordinates x2, y2. Let's say it divides this line segment in the ratio A to B. Okay, so if this is a scenario, then the coordinates of that point in the center is going to be, we're going to have x sub P is going to be x1 plus A over A plus B. So x1 is basically the x coordinate of the first point, which is A, and A over A plus B is a ratio of the distance from x1 to x sub P. So multiply that by the entire length to get the exact distance, x2 minus x1, basically the run because you're going in the x direction. And then y sub P is going to be y1 plus the same ratio, A over A plus B, times the rise, y2 minus y1. Okay, so let's apply this formula to this problem. So we have the first point, x1, y1, we're going from x to y. Okay, so we have x1, y1, let's call it the first point, is going to be point x, which is -6, comma, -2. And then our second point, x2, y2, is going to be point y, which has coordinates 6, 7. And then the point in the, somewhere in the, between these 2 points that divides the segment, point P, xp, yp, that's what we're looking for. Okay? Now the ratio A to B in this problem is 1 to 5. Alright, so with this information we can specify exactly what each component are, and then we will plug them into the formula when determining the coordinates of x sub P and y sub P. Alright, so x1 is going to be -6. Y1 is going to be -2, as you can see here. And then x2 from the second point y is going to be 6. And then y2 is 7. Using the ratio, we can clearly see that A is 1 and B is 5. Okay, so let's find the x-coordinate of the point. The x-coordinate is going to be, let's rewrite the formula, x1 plus A over A plus B, basically the fraction of the entire length. The entire length is your run, x2 minus x1. Okay, so this piece right here gives you the distance from the original point, and when we add it to the x-coordinate of point the first point. What is the first point? Point x. It gives us the x-coordinate of point P. Okay? So let's substitute. X of P is equal to x of 1, negative 6 plus a, 1 over a plus b, 1 plus 5, times x of 2, 6 minus x of 1, minus 6. Now we're going to use the order of operations to simplify this expression. So we have negative 6 plus 1 over 6 times minus is plus, you slash and dash. 6 plus 6 gives you 12. Now you can plug this in your calculator or work it out by hand. I'm going to do this by hand. We have negative 6 plus 12 over 6, which is negative 6 plus 2. Negative 6 plus 2 is 4. So that is the x-coordinate of the point between the segment that divides the segment in the ratio 1 to 5. Now we need to find the y-coordinate. Let's write down the formula for that. y1 plus a over a plus b times the rise y2 minus y1. Okay, so y sub p is going to be y1, which is negative 2 plus a, 1, a plus b, 1 plus 5, times the rise y2 is 7 minus y1, which is negative 2. Now let's go ahead and work this out. We're going to have negative 2 plus 1/6 times minus, slash and dash, as a plus 9. That gives us negative 2 plus 9 over 6. Now if you simplify this, you have negative 2 plus 3 over 2. You find the LCD by expressing negative 2 as a fraction, and then you times it by 2 top and bottom. Remember, denominators of fractions must be identical in order for you to combine them. Okay, so this combines to give you negative 1 over 2. So the coordinates of point P is going to be x, this is supposed to be negative 4 for the x, and then the y is negative 1/2 for the y. Let's write that again. So x is negative 4 and the y is negative 1/2. So the answer for question number 18 is option number 4. Okay, now that we've solved the problem, let's go over a visual way to basically understand what's going on. Alright, so I'm going to call this a visual approach. You can use this approach to solve the problem. Let's say you forget what the formula is. If you consider the visual approach we're about to use, then you can also solve the problem without any complications. Okay, so we have 2 points. We're gonna label the points. I'm not drawing it to scale. Okay, so the points are x and y. So let's just graph 2 points. So we have point x right here, and then we have point y, let's say somewhere over there. Okay, so point x has coordinates negative 6, negative 2 for x, and then point y has coordinates 6, 7. So this is the segment that we're talking about right here. This segment is divided in the ratio 1 to 5, and point P is somewhere in between these 2 points. So if it's in the ratio 1 to 5, imagine breaking this line into 6 parts, and then the first part will be where point P is located. Okay, and we don't know what the coordinates of point P are. So what we did in this problem is we split up the problem. Okay, we looked at the x piece and the y piece separately. Alright, so let's take a look at the x direction first. So for the x, in the x direction, we're looking at the horizontal movement. So this is the x direction. Alright, so the x projection right here will be split in the same ratio. Okay, so what we just have to do is calculate this length right here and add it to the x coordinate, and that will tell us the x coordinate of point P. So how do we calculate this length right here? We want to calculate the length from here to here. Okay, so that length is basically 1/5 of the entire, I'm sorry, the length is in the ratio of 1 to 5, these two segments right here. So this length is going to be 1/6 of the entire segment. Okay, so since it is in a ratio of 1 to 5, here this portion is going to be 1/6 of the entire length. The entire length is going to be -6, 6 minus -6, which is 12. Okay, so that length right there is 2. So if this length is 2, and you add it to the x coordinate here, that tells you the x coordinate of the point P, which is -6 plus 2, which is -4. Okay, so remember, it's in the ratio of 1 to 5. So this is 1/6 of the entire length. Okay, so this is 2. And then if you look at this side right here, what do you think is going to be? It's going to be 5 times the first segment, which is 10. Does that make sense? It should, because 2 plus 10 is 12. Alright, so what we're doing is basically sharpening up this side, this horizontal projection, into portions according to the ratio. Okay, now the same applies to the y direction. So let's say we have take a look at the rise here. Okay, we're gonna split it in the ratio 1 to 5. That will, and then when we split it in that same ratio, we can use that ratio to determine how long this portion is right here. Okay, so what we're going to do to calculate the length from here to here is we're going to calculate 1/6 of the entire horizontal span. 1/6 of 7 minus -2. If you count from -2 to 7, you're going to have 9 units. Okay, 1/6 of 9, and that gives you 3/2. Alright, so that's how long this portion is. So this portion is 3/2, and the remaining portion is 15/2. And then when you add 15/2 and 3/2, you end up with 18/2, which is a total of 9. 18/2 is 9. Okay? Alright, so what we did in the work we showed earlier is that we took the y coordinate -2, and we added 3/2 to it. -2 is the same thing as -4/2. If you add 3/2 to it, that gives you -1/2. Okay, so this is just a visual rendition of the problem, just to help you gain a deeper understanding as to what the formula accomplishes via the computations that we just did. Alright, let's take a look at question number 19. It says in circle O, diameter AB, chord BC, and radius OC are drawn, and the measure of arc BC is 108 degrees. Some students wrote these formulas to find the area of the sector. So we have Amy, Beth, Carl, and Dex's answers. Which students wrote correct formulas? So we have pairs, which means that 2 students are correct. Okay, so one thing you want to remember is that a sector is the fraction of the area. Okay, so it's like you're taking a slice of pizza. The entire pizza is the area, so if you're taking a sector out of it, it's like you're taking this slice of pizza out. Okay, so think about sector as a fraction of the area. Why is this important? Well, there's another formula that has to do with arc length, okay, and that deals with the circumference. If you know what you're dealing with, what you're taking a fraction of, it helps you determine the correct formula. Okay, so since we're dealing with area here, we know what our area formula is. The area of a sector, the area of the fraction of the entire area, let's write it down, is given by what? Formula. Um, area of a sector, let's write down the whole thing. Area of a sector is the fraction of a whole. So a whole is 360. The fractional component is the degree indicated. So let's just call it theta divided by 360 multiplied by the area, pi r square. Okay? Alright, so let us see which of these students accurately applied this formula right here. Okay? So theta in this problem is the angle, okay, which is 108. Measure of the arc, 108 degrees. R, the radius, can be written in different ways. Okay, you can call the radius AO. You can call the radius AO or BO, or you can call it 1/2 of AB. That's the same thing, or you could call it OC. All these represent the radius. As long as you're going from the center to the circumference of a circle, that's the radius. This is AO. This is OB. When you go from A to B and divide it by 2, you're either going to end up with one of them, doesn't really matter, or OC, which is R. So different ways of writing down the radius. Okay? So let us see who is correct. Based on the value of theta alone, we can eliminate options. So Carl put 3/10. What is that? That's not correct. So Carl is wrong. Amy put 3/10. So Amy is wrong. We have Beth and Dex. Looks like that's the answer. Answer is option 4. But let's just verify. Okay. So the situation with Beth, theta over 360 times pi r. R is OC. That's perfect. So this right here is R. And that's theta right there. Okay. But in case of Dex, this is theta. Good. R is half of AB. See, half of AB. That's R also. Another way to write R. So he's correct. And Beth is correct also. So that's why our correct answer is option number 4. Okay, let's take a look at question 20. It said tennis balls are sold in cylindrical cans with the balls stacked one on top of the other. A tennis ball has a diameter of 6.7 centimeters. To the nearest cubic centimeter, what is the minimum volume of the can that holds a stack of 4 tennis balls? Okay, so what are we talking about here? If you play tennis, you'll totally understand this problem, but take a look at this photo right here. This is a kind of setup that we're referring to in this problem. Normally, there are 3 balls in the container, but this problem is strange. It has 4. Okay, so let's see. It says 4 tennis balls. This one is a case where we have 3. Okay, so what if there are 4 balls? What's the volume of the can? The volume of the can, which is a circular prism or a cylinder, what is that volume going to be? So let's give ourselves a visual of the scenario. So first of all, let's write down a formula. So we're looking for the volume of a can or a cylinder. So the volume is going to be what? Area of the base times the height. So let's go ahead and draw the tennis balls. So we have one right there. Okay, so there goes my strange looking sketch there. Now, what you want to keep in mind is that we're looking for the minimum volume. Okay, so if we're minimizing the volume, it has to be packed in such a way that the balls are touching each other. Okay, it's packed tightly. Okay, so what we're looking for is the volume of this can that is holding these four balls, identical tennis balls. Now, let's see. We can basically use the dimensions of the tennis balls to determine the radius and the height of the cylinder or the can because it's packed so tightly. Okay, so it's packed in such a way that the radius of the ball, so this is the radius of one tennis ball, is exactly the same as the radius of the cylinder. Okay, so what do we have here? We're told that the radius of the tennis, no, the diameter of the tennis ball is 6.7. Okay, so if the diameter of the tennis ball is 6.7, the radius is going to be 6.7 divided by 2. Okay, so that's 3.35 centimeter. Okay, this is for the tennis ball. Okay, but since it's packed in such a way that the radius of the tennis ball is equal to the radius of the can, so let's write that down. Since the radius of the ball is equal to the radius of the can, so let's call this R of t, d of t. The radius of the can, let's call it R sub c, is also going to be 3.35. Okay, great. We have one part down. Now, the formula is dependent on the radius and the height. So we know what the radius of the can is. It's 3.35. So what else do we need? We need to know what the height is. So from here to here, R is 3.35. Now, how do we figure out that out? What we know is that it's packed so tightly that the diameters of the four tennis balls just line up perfectly like that. You see that? So how many diameters do we have? We have a total of 4 diameters. The 4 diameters of the tennis balls basically is equal to the height of our can. Okay? So the diameter of the can, the height of the can is equal to 4 times the diameter of the tennis ball, since they're arranged in this format. So what we'll do is just take 4 and multiply by 6.7, and that will give us the height of the can. Alrighty, so let's go ahead and do that real quick. So we have 4 times 6.7, and that's 26.8. So it's 26.8. Okay, we are now ready to determine what the volume is. Okay, so the volume of the can, let's refresh our memory, is pi r radius of the can square. Okay, this area of the base multiplied by the height of the can. So we have pi times radius of the can, 3.35 square, times the height of the can, 26.8. Let's go ahead and enter that into our calculators. So, and we're going to be rounding to the nearest cubic centimeter. Okay, so we have pi times 3.35. Sorry, I'm supposed to put my parentheses. 3.35 square times 26.8. Close that, enter. 944.87. Since we run into the ones place and the digit behind is 5 or greater, we'll round up. So we have 945 centimeter cube. Answer for number 20 is option number 4. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place it in the comment section below and we'll be more than glad to support you. Do subscribe to our channel for updates to the remainder of this review series and other math content that we upload to our page on a consistent basis. Feel free to visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.